Today we learn about the delete operation on the max heap. How to delete any node from the max heap. Okay. In the last video we learned about the insertion operation on a max heap. How to create the max heap depending on the all other nodes. Okay. These are some steps to delete the node from the max heap. Delete the node. Next step is replace the deleted node with the furthest rightmost node that is present in our tree, and then apply the heapify operation. That is nothing but check the heap max heap property. The max heap property says that the parent node have the value is greater than its child node. If the heap property holds, then you are done, and if else if replace the node its parent, then swap, then repeat the step number 3 again and again up till you get the max heap. Okay, now we see one example. Suppose this is a given tree that contain these many number of nodes, that is 15, 14, 8, 12, 9, 1, 5, 10, 3, 6 and 7. These are the nodes and that is a max heap. Okay, in this particular tree you have to delete the 7. For delete the 7, check the 7 is a leaf node, that is a furthest rightmost node present in this particular max heap. Okay, we have to calculate level wise. This is level 0, level 0, level 1 and level 2. Okay, this is the level 0, then level 1, level 2 and the level 3. Which one is the last element? That is a 7. When we do the array representation of this particular max heap, then the 7 is get at the last of your array element, means 7 is the last element of your array. And suppose you have to delete the 7. For that purpose simply you have to just delete the 7. Okay, just delete the 7. After deletion of the 7, the tree will be like this. Okay, this is the delete operation on the max heap when we delete the leaf element. Okay, now delete the 15. 15 is a root node of our tree. Suppose this is a given tree. In this particular tree we have to delete the 15. Okay, now we see the step by step. First of all, for deletion purpose, the step 1 says that replace the 15 with the furthest right node. Which node is present here? Suppose when we do the array representation of this particular tree, suppose the 15 will be here. How we can do the array representation? Then 14, then 8, then 12, 9, 1, 5, 10. Okay, after the 10, 3 and 6. Which one is the last element here? The 6 is a last element. Okay, 0th location, 1, 2, 3, 4, 5, 6, 7, 8 and 9th location. At the 9th location 6 will be present. The first step says that for deletion of the 15 we have to replace that 15 with this particular element, that is the last in our array representation. We can say that, as well as we can say that the furthest right node of our tree. Okay, just replace that 15 with the 6, and after the replace the 6 will get deleted. Okay, now the tree will be like this. Okay, this is the step number 1. But we can see that the 6 is a less value than the 14. It does not follow the property of the max heap. Okay, then in the step 2 we have to apply, or we have to check the max heap property of max heap property. Okay, in this particular situation the 6 is less than the 14. It means that it does not follow the max heap property. For that purpose we have to swap the 6 with the 14. Now check the parent of 6. Parent of 6 are 14 and 8. Which one is a greater value? 14 is a greater value. Okay, for swapping purpose we have to check, because these 6 having the 2 childs, 14 and 8. From this, which one is a greater value? The 14 will be the greater value. That's why we have to replace the 6. Not replace, we have to do the swapping with the 14 and 6. After the swapping the tree will be like this, means 14 is here and the 6 will be here. Okay, again we have to check the heap property on this particular tree. If it is follow the heap property, 6 is less than the 12, it means it does not follow the max heap property. Here again we have to check the child of 6. 12 and 9, which one is a greater? 12 is a greater. That's why we have to again do the swapping between the 12 and 6. Okay, in the step 3 we have to do the swapping of 12 and 6. The 12 will be here and the 6 will be now here. Okay, again check the maxi property on this particular tree. Then we have to find that the childs of the 6 are 10 and 3. The 10 is greater than the 6. From these two childs the 10 is a greater value. Again we have to do the apply the swapping between the 6 and 10. Okay, between the 6 and 10, the 10 will be here and the 6 will be replaced by here. Okay, now this one is a final tree and that satisfy all the heap property. Okay, this one is a final tree. After deletion of the 15, the 14 will be root now for the max heap. Okay, this is a simple delete operation on the max heap that we have to apply depending on the situation. Okay, thank you.